Hey guys, John here, and welcome to episode 6 of Next Level Retro. So, last episode we talked about the memory map on the Commodore 128, and today I want to demo how to switch screens. And if you're building a game for the Commodore 128, um, it's kind of cool to know, how to switch scenes in your game. So, what I'm going to do here is you can see I've got these three sort of screens. Uh, John in the top right hand corner. Then you have this kind of little racetrack here. Welcome to auto racing, and I did this one in color, but then I forgot to copy the color information to the code. So the demo is actually going to be in monochrome, that light green. Okay, and then we have sort of like a parking lot. So what I'm going to demonstrate is how to tell the VIC-II chip to rapidly switch scenes or screens. And it's kind of cool. It's kind of a cool feature because when you're writing a game, you definitely want to be able to switch levels or scenes in your game rather quickly. And at some episode in the future, we'll also look into how we can smooth scroll our scene. Okay, so let's just get right into it. Um, We're gonna look at just a high level memory map here. Let me bring up my Excel and I'll show you. So if you recall from the last episode, we have our high level memory map, RAM bank 0 and 1. And here we can see that, zoom in there. I think it's time to get a new computer, guys. Okay. So here we can see that the VIC can only see 16K of memory at a time. This is important to know. Um, and also, it's good to know that what the VIC can see is not necessarily the same as what the CPU can see. And we will get into that shortly. Okay, and then we have RAM bank 0. And this is where we're going to stay. We're going to stay in RAM bank 0 when we're doing this demo. Now, quickly, I want to emphasize or um, refresh our memories on the fact that the 40 column screen, hope you can see that, the 40 column screen resides in 1K between 400 hex and 07FF hex. Let's bring up the screen where we can see both hex and decimal. So here we have, you can see that here we have 40 column screen RAM resides in 1K, and it resides between address 400 and 7FF, or 1024 and 2047. Okay. So what we're going to do in our game is we're going to use the default screen location as sort of a menu where we can hit keys. Depending on the key we hit, it'll switch the scene for us. Okay, and what we're going to do is we're going to put the we're going to have the main screen here. Then we're going to have screen number 1. We're going to call it screen number 1. We're going to have it here, starting at address hex 2000. And then screen 2 is going to reside in the 1K starting at hex 2800. Okay. And actually, no, I apologize. These are all 2Ks, so Let me bring over. You'll have to forgive me. Here we are, and here we are with the So we're gonna look at VIC Bank 1, and I apologize. Let's backtrack here because I didn't have the right tab open. So let's refresh. The 40 column screen RAM by default resides in 400 to 7FF, and that's 1K. Right? It takes 1K, less than 1K actually, 1,000 bytes to fill up the whole screen, the whole 40 column screen, 40 by 25. So our main screen, as we said before, is going to go here, 1K. Then we're going to have our, what we call our screen 1, will go here, right, which is at starting at memory location 2000 hex. Screen 2 will go here, 2400 hex. And screen 3 will go here at 2800 hex. Now, if we start putting screen data here, here, and here, we run the risk of either overwriting our BASIC program or BASIC overwriting our screen data. What I mean by that is, right here is where BASIC text starts, right at address 1C00. Right? That's where, by default, the Commodore 128 starts storing its basic text, program text. So we're going to have to tell the Commodore 128, or I should say the Commodore 128's kernel, to move the start of BASIC up. And we're going to move it, in fact, we're going to move it up to this location here, hex 2C00, or decimal 11,264. Okay. So if we start here, we will have plenty of RAM here to put our code. And actually, it's not that large, so it will not even take up all this memory. But now we have this to put screens 1, 2, and 3. And of course, we still have our main screen, which is our default screen location. Okay. But you might be wondering, hey, why are we starting screen 1 here and not here? Because we moved basic RAM up. Well, what's important to note is that what the CPU sees and what the VIC-II sees are two different matters. Okay. We can tell the CPU to put screen data here. Okay. And it will gladly do so. The problem is that, and I won't get into this too much into this video, but by default, the VIC-II sees character ROM from here to here, right? It sees character ROM, right? So even though we can update this RAM, right? We can update it with screen data. Let's say we could, if we wanted to put our screen 1 data there, we could definitely do that, and the CPU will see it. CPU will write to it and see it, but the VIC-II will not see it. The 128 is set up to tell the VIC to see character generator ROM at these two addresses. Okay. So I won't even look at the RAM. And that's why we're starting at 2000 for screen 1, 2400 for screen 2, and 2800 for screen 3. All right, so enough of that. Let's start. Let's just start coding. Bring up a screen that you can see here. Hopefully you can see that. Okay. Sorry, guys. I hope this won't take too long. Let's okay. There's just too much going on here at the moment. Okay, so like we said, the first thing we want to do is let's create a program that's kind of our booter. It's our boot program. So I'm going to start with writing some code. We're gonna start at. Hopefully you can see that now. Another thing too that I like is I like to code in the 80 column mode. So that's what I'm going to do. I'm going to switch over to 80 column mode. It's just 49194. Okay, so hopefully you can see that. Let me switch over. It's time to get a new computer. Computer's acting very slowly. Okay. Let's clear the screen. Let's have a look at our okay. We have a disk that's not named anything. I'll worry about that later. Okay. So the first thing we want to do is we want to move BASIC. I'm going to start by poking the value 44 at address 46. And also poking. Now, let's look over at the Excel reference sheet here. Now we said we were going to move it to here. Okay. Okay. So in fact, what the poke 46, 44 does is actually tells the kernel to move BASIC up to here, 11264. But at that location, at 11264, we have to poke a 0. Okay, so we moved BASIC. Now, if you want to know what address 46 does, we just explained it, but if we quickly look here at my Excel, which hopefully you can see, address 45 and 46 store the address where BASIC should start. So by default, location 45 is 0, 1. Let's zoom that in for you. And 46 is 1C. And we did say that by default, in cold boot, BASIC starts at 1C01. Okay. what we want to do with some math then is basically change the 1C here to a 2C hex, which is 44 in decimal. Okay, we're not really going to change the lower endian or the lower byte. I will leave that 01. But just keep in mind that 2C01 is actually 11,265. That's where BASIC will start, but we have to poke a 0 at the address before the address where BASIC starts. So that's what we're doing. That's what we're doing here. Okay. Let's get back to Commodore 128 screen. Okay. And then I'm going to just use this as a bootloader. So I'm going to load, we'll call it S1 loader for screen 1 loader, and we're going to run this right after we load it. Okay. So I think that looks good. Let's now save it. I'll save this as episode 6. Okay. Now, we're going to create a second program. And let me go into a better view for you guys to see. Hopefully that's a bit better. I'll take the captions off. That's the captions. Okay, so hopefully you can see that. All right, so let us now start with screen 1. Let's move some windows here so you can see me a little bit. Okay. Okay, so the first thing we got to do is we want to, let's say, okay, so we need to save the address where screen 1 is going to be stored. So I'm using the basic7 dec function, which will convert hex to decimal. In BASIC, we need to store decimal values and variables, but I like to reference hex. So remember that we said we want to store screen 1 at location 2000 hex, and that's what we're going to do here. We're going to create a variable AD for the address, and then we're going to loop at every row column on the screen. And if you recall, we did this in a previous episode. So I'm going to do a for loop, x equals 0 to 999 for 1,000 locations on the screen, right? If you recall, we have 40 columns across, 25 rows down. You multiply that, that gives you 1,000. So we're going to do a for loop. And then we're going to read from a bunch of data statements that will be coming. And we want to poke. So read A basically is reading the decimal screen code for each cell on the screen. And the key codes represent a character. So we're going to poke 80 plus x, comma, a. Okay. And then we're gonna load screen 2 loader, which is basically gonna load the screen, or the screen data for screen 2, and then we'll run it. Now we're gonna store our data in data statements, and with the magic of TV, I'm just gonna paste this right in. Okay, so what I'm all right, let's just wait for that. It's almost done. Okay, so let's save that now. Let's call it, again, we're gonna call this S1 loader. S1 loader. And again, this is going to load our screen 2 into memory. Okay. So what do we have to do for screen 2? I'm sorry, that was screen 1. What are we going to have to do for screen 2? Well, I'm going to delete the data for screen 1, which we know starts at line 5000, so I'm going to delete it. I'm going to list what we have. So the program for screen 2 is essentially the same, except we're going to change location. So we're going to put screen 2 at location 2400. And after that's done, we're going to load the screen 3 loader. Okay, but then we have to put the data statements in there. So again, by the magic of TV, it's going to paste that in. And so these codes represents the screen for screen 2. And thanks for bearing with me on that. Okay, so now let's save this as S2 loader. And let's just make sure yeah. And so S2 loader is calling S3 loader. Okay, that's good. So far we have episode 6, S1 loader, S2 loader. Okay, and now once again, we're gonna delete lines 5,000 and onward. We're going to list the rest of the program. So now we're at screen 3. So what did we say about screen 3? We wanted to store it at location 2800. 2800. And then we don't want to load any other screen loaders here, but we're going to load let's call it screen selector. Make a mess of this. Call it screen selector and run it. Okay. Let's paste that in. You can see that there are a lot of 32s. 32 is space. And if you recall, this is the last screen, which is just my name, John, in big giant letters, graphical letters. And so that's why a lot of the screen is blank or spaces, for which the screen code is 32, ASCII decimal 32. Okay, we've done that. Now we're going to save this as S3 loader. S3 loader. Okay. So what's left to do then? Well, we have to code the screen selector. Okay, so let's, Vice doesn't want to stop my drive. Okay, so then let's start with a new program, and let's, okay. Now, before we get into that, I want to explain how we tell the VIC which 1K block of memory to look at to draw out the screen. So I'll bring up my Excel again for you guys to view. Okay. Bring up the screen of VIC registers. Now, we kind of looked at this briefly. We said that we want screen 1 to be at 2000, screen 2 to be at 2400, and screen 3 to be at 2800. Okay. Now, without going into too much detail, we have what's called a shadow register, which is hex A2C. Okay. And to tell the VIC to look at a specific 1K block of memory for drawing out the screen, we have to populate this register with the value corresponding to the memory location. Now, there's some more to it than just screen location. This register also tells the VIC which memory location to look for character data. Okay, but we're going to leave the default, which is 0. In binary, it's 0100. Okay, for the lower 4 bits of the byte, and for the upper 4 bits of the byte, this is important to us. This tells us this tells the VIC where to look for screen data. All right. So when we combine the two, we come up with these hex values or decimal values. So for screen 1, we want to put the value 84 in that register. And for screen 2, we want to put the value 94 in that register. And for screen 3, we want to put the value A4 hex in that register. Okay. Now that's for telling the VIC where to look for screen data. The kernel and screen editor interrupts are still running and working. Now, for our program, for our demo, we actually don't need to do this, but it's a good habit. Register 0A3B tells the kernel and it tells the kernel at each screen editor interrupt where to look for character and screen data. So again, this is just for the kernel to know where screen data is located when it's generating the screen editor. So for the default 40 column screen RAM, the value is going to be 04 hex. For our purposes, when we want to tell it to look, when we want it to draw out screen 1, we need to put the value 20 hex in that register. For screen 2, 24 hex in that register, and screen 3, 28 hex in that register. Okay, so we'll keep those in mind, and I will go back to 80 column screen editor, which I love. Okay, and let's start coding. All right, so we talked about those 2 registers. So what I'm going to do, let's start off with defining those 2 registers. Remember, we said they were hex 0A to C. And then we also had register 2, that is 0A3B. Okay. And we're going to clear the screen. And then we're going to print a nice welcome message. Welcome to Next Level Retro. Episode 6. Type one of the following keys of course I want to number it properly, 130. So then type one of the following keys to select a screen. A to select screen. A to select the main screen. My keyboard going already? Main screen. We'll say this one. Hit the S key to select screen. Screen 1. The D key to select screen 2. And of course we did this again. It's 160, 170, and 180. The F key because those are all adjacent to each other. A, S, D, F. I misspelled screen. Select F for screen 3. Okay. So far, so good. Let's just run this and see what it looks like so far. Of course, we're not going to do this in 80 column mode. We'll run this in 40 column mode. So now that we have a nice little menu, what we have to do is scan the keyboard. So we'll start at 500 and call the variable K, and we'll memory location 213 stores the key code for the last key that was pressed. So we'll look at it. And we'll store it in the variable key. Now, if K equals 88, that's so 88 is the key code. It's not a key code, it's the value when no key is pressed. So that's to say that if no key is pressed, then we'll go to 500. In other words, keep scanning, and keep scanning. So at 520, if K equals 10, which is the keyboard code for A, then we'll go sub 1000. Say rem A pressed. Then for 530, if K equals 13, which is the key code for S. So if K equals 13, then go sub 2000. Rem S pressed. And for 540, if K equals 18, go sub 3000. This would be D. And for 550, if k equals 21, then go sub 4000, and that's F pressed. Okay. So now we got that happening. But if none of them are pressed, and we simply go back to 500. So let's put 560, go to 500. That should do it. Now we will now start with the page flipping routine, which will start, of course, at 1000. We'll put a rem here. We'll put a remark, show main screen. And then at 1010, we'll poke. Again, I like to work in hexadecimal. So we're going to convert a hexadecimal to decimal. And we're going to poke register 1 that we defined. Register 1. We're going to poke it with, in this case, we're going to poke it with 14, as we saw from the Excel spreadsheet. Okay. Telling the VIC where to look for screen data. And then we're going to tell the kernel where to look for screen data. And that's 04. So I think we have it 14 and 4, and then just put a return from go sub here. Okay. So 2000 is going to be very similar. And in fact, 2, 2, 2, 2. This is going to be the show screen 1. And we're going to poke 84, as we saw from the Excel. And 20 to those two registers. Okay. Then we'll go to subroutine at 3000. And here we're going to show screen 2. Let's make sure we hit enter. Did something down there. So here so here now we're going to poke X94 to register 1 and 24 into register 2 and return. And last but not least, we have subroutine at 4000. And here we're going to show screen 3. And we're going to poke A4. And 28. Let's just double check our code. So let's list 1000 to 2000. Looks good. And 2000 to 3000. And that also looks good. And that's screen 1. And then list 3000, 4000. We're going to get screen 2. And then finally list 4000 and onwards. That should be screen 3. Okay. And now we're going to save this as, we said screen door. Okay. All right. So let's head back to Commodore 128 here. Or 9194. That takes us back to the, what do you call them, mode? And let's just focus in on that one. Okay. So let's just make sure all our programs are there, which they are. We have episode 6, we have the loaders, and then we have the screen selector. I'm going to do a hard reset. I'm going to put in my diskette. I think my diskette is already there. All there. We're going to load episode 6. And let's run it. And we're going to have to wait a bit. Let's see if this works, guys. Just waiting for it to load. I suppose I could enhance this to put like progress bar or percentage progress status. All right, we have a syntax error in line 301. Not sure what I did. Okay. List 1, 2, 400. 301. Yeah, that was from a previous. So let's just take that out. That's the screen selector. Let's list 1 to 1000. Let's see if it's still clean. Okay, now I want to list 3000. Let's make sure that's clean.
Policy Braga, or 2 others.
Sorry guys, I had an important call. So that looks good. Let's resave this. screen selector. And save this as screen selector. Let's now run this. Alright, so no errors this time. I misspelled retro. So let's start with screen 1. Alright, so there's our parking lot. I'll hit the D key, and we have our racing game. Recall that I forgot to save the color information, so I apologize. Perhaps in the next episode, we'll introduce color into these. I'm going to hit the F key. There's my name, John. So let's head back to the main screen. Oh, and I have a funny character in there. I suppose I need to, and there's a funny character. There's a block right after auto racing, and there's a block in this scene as well. So I'll have to look into that. Let's go back to the main screen, hit A. Okay, so look how we can rapidly change screens. So the VIC is pretty quick, refreshing. I mean, that is pretty quick. Now, note one thing. If we're going to try to break out of this program, we can't do it here or here. Okay. Actually, I think we can. Yeah, and we can. But now, we're telling the VIC and the kernel different locations for the screen and for the screen editor. Okay. But if we run it again, and hit A, let's go to S, D, F, and now we're back to A. Now we're back to default memory location for the screen and the screen editor. So now we can hit escape and we're done. Now, I did a little modification there. So let's do a hard reset. And I'm going to show you something cool too. So I'm going to bring up both that and that. And I'm going to I'll increase this. Let me bring this out of the way for you. Bring this one back up. Move it over to this side. And I'll get out of your way here. Now I'm going to go back to 80 column, 49194, and I'm going to load I'm going to load episode 6. And I'm going to run episode 6 and let it run. And when we finally get to the screen selector, you'll see that it'll show on the 40 column display. It'll take a minute, but it'll get there. Now, you see what's happened? I guess I lied, didn't I? Okay. So to get this to work, you have to be on the 80 column screen, which I am now. I'm on the 80 column screen, but you can see that I have the menu on the 80 column screen. Welcome to Next Level Retro Episode 6, etc., etc. So here I am. I'm going to type S and watch the 40 column screen. All right, I have the parking lot. We have the auto racing thing. And we have John. And then we're going to go back to the main screen. Well, in this case, we're not going back to the main screen because the last thing that the VIC saw was when we switched to 80 column. When we typed in the sys command sys 49194. So that's the last thing it saw. So our main, our cert, well, it is our main screen, but our menu now is on 80 column mode. So I think that's pretty cool. Let's try this again. So I'm hitting A, nothing happens, but when I hit S, we got our parking lot. It's a dumb parking lot, I know. I just whipped this together. If I hit D, I'm on Welcome to Auto Racing F, right? So I think that's pretty cool. So anyway, guys, I guess you can say that's sort of the start of a game. We made some scenes, some screens, however you'd like to call them. You know, we have screen one. Let's say we're entering our parking lot. We want to watch the race. Then we go to the race, and then finally, John wins the race. All right, guys. I hope you enjoyed that. If you have any questions or comments, please be sure to leave them in the comment section. And if you like this video, please be sure to share, like, and subscribe. Thanks a lot, and see you on the next video. Bye for now.